Okay, good morning. Happy snow day to everyone. I have assigned you homework due for today, and I will be assigning something else also after I want you to watch this video to submit it to me related to graphing inverse functions. So I want us to go over this detailed example together, then it will be helpful for you to perform both today's homework and the one that I have assigned from last night. So the question is, let f of x is x squared minus 3. I want us to graph f of x first and then find its inverse, but thinking that there might be some restrictions on the original function f of x if necessary, then figure out what is f inverse of x and identify its domain and range. So let's put that there. Also, we need to write f inverse of x as a function rule. So f of x is a function with the toolkit function x squared is pulled down 3 units, and this red dashed line is y equals x line that we are going to think the inverse of f of x. So we can take the inverse of f of x directly by thinking algebraic rules of it, but then we might be doing a mistake because the function that we have obtained might not be a function, since not every x value uniquely assigned to a y value, meaning that I have many x values on the f of x function has been assigned to same y value. If we think about an x value of, let's say, -2 here and +2 is going to same y value. So f of x is not one-to-one function, meaning same x values, different x values have been assigned to same y value. And x values have been assigned to same y value. So that should bring us a warning that in that case, if I just go ahead and obtain f inverse of x by thinking algebraically, f inverse of x will not be a function. Okay, so we definitely need a restriction. We need that restriction on f of x domain. And that restriction will reflect on f inverse of x range because of the definition of inverse function. Alright, so the restriction we're going to take, we can choose, since the values are happening on both sides of the parabola, we can either choose the right hand side of the parabola or left hand side of the parabola. We are free to do that. So we're going to start first, how are we going to choose the domain and the range, both for f of x and f inverse of x. For that, I need to look at the vertex of f of x. I want you to remember the standard form of quadratic function. So our f of x is x squared minus 3, then the vertex of our f of x will be equal to 0, negative 3. So the vertex starts with axis of symmetry, which is negative b over 2a, which in this our case, our b is 0. Here we don't have any x term, over 2a, which is over 2. So our vertex coordinates, x coordinate value will be 0, and if we go back and plug in 0 on f of x, we're going to get negative 3. So this is going to give us the coordinate values of vertex. That's why we have 0, negative 3. So by looking at that vertex, the x value of that vertex is going to tell me which side of the parabola I can take. So domain of f, I will be taking x is greater than 0. Then in that case, range of f will be equal to y values greater than equal to negative 3. That's one option. Or I can take domain of f x values less or equal to 0, then range of f y values again greater than equal to negative 3. Either or. I can choose. So hence if we choose this part, okay, then that's going to bring us a range and a domain of f inverse of f inverse. So range of f inverse of x will be y values greater than 0. Domain of f inverse of x will be x values greater than equal to negative 3. So I will follow with this column by obtaining table of values, both f and f inverse, and obtain the graph. This is prepared for f. Let's say this one for f inverse of x. So my x and y values for f of x here. Let's pick up some values for x greater than 0, and let's reflect them for f inverse of x as x and y values. I can take x1, actually I can start with x equals 0, 1, and 2. So if I can plug those values in x squared minus 3, this was my function, pick it up here, then I will obtain negative 3, I will obtain negative 1 minus 3, negative 2, I will obtain 1. So then when I look at my f inverse of x values and look at my range, the values I should be taking should be greater than -3. Then I need to be obtaining the values y greater than 0. Right? Then at this point we do not have a function rule for f inverse of x. Let's try to obtain that. So y equals x squared minus 3, switch x and y, and solve for y. So x plus 3 square root will be equal to y. That will be plus or minus. Then we are going to write down y equals x squared square root, yeah, correct, plus 3. And which one do I need to get? That's what I need to decide. So hence here I have negative and positive options. Because I have decided to go with domain of f inverse of x, x value is greater than -3, I should be taking the positive one, not the negative one. So negative is eliminated because of my domain. So I need to keep that. Then it gives us f inverse of x positive x plus 3, and the values that I should be taking, x values greater than or equal to -3. So I can take the same x values here, put that as domain, starting from -3, -3 positive 3 is 0, square root of 0 is 0, so when I take x is equal to -3, and I take x is equal to -2, -2 plus 3 will be giving me 1, square root of 1 will be 1, because y values will be greater than 0. The same thing could be done for x values equal to 1. 1 plus 3, 1 plus 3 is 4, square root of 4, positive 2, -2, but we're choosing positive 2 because our domain will be greater than 0, so that will be 1 and 2. Now we can put both of them on the same graph. Okay. So we wanted to have f of x is equal to x squared minus 3 when x values are greater than 0, greater than or equal to 0, and we want to get f inverse, which means that those two functions will be symmetric, y equals to x-axis, and that one will be starting from -3 here and going this way approximately, and that is f inverse of x equal to square root of x plus 3. So I will be posting a homework very similar to that example, and I'm going to ask you to submit that to me by 5 p.m. today. I remember we talked about it in detail in class many times, but I just wanted to go over it once more with you. So I hope this approximately 15-minute video will be helpful for you to perform today's homework, which you will be submitting online through Canvas. Thank you guys.